This recording is on worksheet B, C, part 3. The question says, do you nullify or reject the second hypothesis? Give a valid reason. Or the second null hypothesis, HO number 2, give a valid reason. So we've got to find out what is HO number 2. HO number 2 was answered in C part 2. Let's check it out. Here is HO number 2. We can put 2 by it just to, because we have HO number 2, HO number 1, we did HO number 1 already. Right. HO number 2 is saying the population standard deviation is greater than or equal to 20. Now, this is what the population, this is what the null hypothesis is saying. So we have to compare what the null hypothesis is saying about the population, compare it to what the data is saying from the sample. So we are comparing what the null is saying with what the sample data is saying to see if there's an agreement or not, to decide if they are different, to reject the null, or if it coincides, to not to reject the null. So therefore, we need to find out what was our population standard deviation, because the null is saying that it is greater than or equal to 20. So let's see what we got. Let us revisit the question before we move on. The question is saying, do you nullify or do you reject the null? Give a valid reason. That is the second null. So now we have to know what the null is saying. We've got to know, because the claim is a hypothesis. It is saying something. The null is a hypothesis. A hypothesis is a statement. So we have to know what is that statement. That second null statement, here it is, because we have completed the pure already in part 2. We prefer the one to the right. The second null hypothesis saying that the average dispersion or difference between the heights or the population standard deviation is greater than or equal to 20. That is what the null is claiming. That is what the null is stating. That is what it is saying. So we need to know, is it true that the standard deviation is greater than or equal to 20? So therefore now, we've got to know what the data is saying now. We need to know what the data is saying. The data is the 10 values in the sample. This is the data that was collected, and the standard deviation was calculated from it. So that data is saying that, and here it is, the average difference or dispersion between the heights, in other words, the standard deviation is 10.55. And we repeated that now with another method, method 2, which is saying basically the same thing, that the standard deviation, which is the average dispersion, the average difference, is 10.55. So the null is saying that the standard deviation is greater than or equal to 20. The data is saying that the standard deviation is 10.55. Clearly, there's a disagreement. What the null is saying is not what the data is saying. And once this is the case, we have to reject the null. So the null has to be rejected because its statement is in disagreement with what was calculated from the data. In fact, the mean is not greater than or equal to 20. It was found out that it is 10.55, which is less than 20. So we've got to reject the null hypothesis for this particular reason. So let's type that up. So therefore, the null hypothesis must be rejected. Why? Because the null is stating that the population standard deviation is greater than or equal to 20. Here it is. Population standard deviation greater than or equal to 20. Whereas the data produced a sample standard deviation of 10.55. Here it is. Clearly, 10.55 is not equal to 20. 10.55 is actually significantly less than 20. So for this reason, we have to reject the null hypothesis.